Alright, so guys, let's start the class. Fully others will join on it. So since it's only two of us here, Sherry and Toby, can you guys just maybe tell me your level of experience with Solidity and Ethereum in general, so I can know how to proceed? I can't hear you.
No,
Hello, am I to speak?
Yeah, like just tell me about your level of experience with Solidity and Ethereum, so I can know how to go about the class.
Okay, the thing is, me, I have not started anything at all. Like, I actually am interested in Web3, but the issue is I'm still in front end. So I joined the class just to like gain whatever I'm able to gain. I'm not even concerned much about like even if I'm able to gain like 3% because I know that I'll still remain them like when I get to Web3. But I'm just in so that when I start Web3, I won't be a total novice and all. So that's the reason why I'm joining the class. Not like I'm currently learning Web3.
Alright, that's cool. What about Toby? I didn't hear you well at that time.
yeah. So likewise, I've not actually written. Yeah, I'm a backend developer basically. So I've not written any solidity before, but I've watched videos on it, but I've not actually written it or written to it.
Okay, okay, no problem. That's fine. So today will be our class. Will be building a cryptocurrency. We'll be building a token, an ERC20 token. So I'll try and explain as much as I can. And if you have any questions, please speak up. And you can send now. Just if you have any question, just unmute and let me know. And if you feel I'm going too fast or something, kindly let me know that one too. So I'll be sharing my screen so you can. So you guys can see the screen, right?
Yes, I can.
Cool. So we're building a cryptocurrency. How to assume, even if you guys haven't really coded Solidity or done something, have you maybe traded, maybe used anything that has to do with? Have you maybe like owned a crypto or traded it or done something, used an exchange or something?
Yes,
Yes,
yes.
definitely. I used to trade like very well.
Cool, cool. So we're building something as an RC20 token, something that will be similar to something with maybe like similar logic to a USDT or other tokens. So you'd see as we go on. So what are cryptocurrencies? So basically, cryptocurrency is typically decentralized digital money designed to be over the internet. Of course, I know we know all of Bitcoin, Ethereum, and other cryptocurrencies as well. Cryptocurrencies are usually not issued or controlled by any government or any central authority. They are managed by peer-to-peer networks of computer running free on source software. So we have several blockchains, layer ones, layer two, and all. And each blockchain, of course, they have their own native token. So a native token is different from an ERC20 token. So native tokens are tokens that are actually tokens like Bitcoin, Ethereum, Matic for the Polygon blockchain, BNB for Binance Smart Chain. So those native currencies are not ERC20 tokens. So those native currencies, whenever we use a particular blockchain, we need a token, we need a currency to pay gas in. So those currencies that will pay gas in are not they are not ERC20 tokens, they are called native currencies. So those ones, example like Bitcoin, Ethereum, BNB, Matic and all. But what we're building today is not a native currency, it's an ERC20 token. So we'll see more on that now. So now our focus is going to be majorly on the Ethereum blockchain. Other blockchains that are EVM compatible, like Polygon, Binance Smart Chain, they follow almost the same logic. So if you understand how Ethereum works, then you can easily build on other blockchains that are EVM. Now, a blockchain like Solana is not EVM compatible, so we have to learn different language, different terminologies, and everything for Solana. But Ethereum, Polygon, BSC, Binance Smart Chain, and some other ones, they are EVM compatible. So basically, it's almost the same thing as using, it's different chains, but the same logic, the same smart contract, the same process as building on Ethereum. Okay. So
Please, sorry for interrupting, please. Like
yeah,
you
so
said, what's compatible? I didn't get that word very well.
okay, I said EVM compatible. EVM means Ethereum virtual machine. So it's basically like the machine that runs smart contracts on the Ethereum blockchain. So it's like it's one. So when you deploy a smart contract, the EVM is the one running and processing everything. So when they say a blockchain is, so Ethereum was like the first programmable smart contract language. Okay, I think Bitcoin was like the first blockchain, but Bitcoin is not programmable. You can't build complex smart contracts on Bitcoin. So the applications of Bitcoin is actually, the applications are really limited when it comes to creating applications on the blockchain. So Ethereum is like the first blockchain that came, and the first blockchain that supports smart contracts, supports building applications on it. So after Ethereum came, some other blockchains too started coming. But since Ethereum was the first one, most developers were used to using Ethereum and using solidity. So they built their blockchain to resemble Ethereum, so that the same language that works for Ethereum, which is solidity, will work for the same language. In fact, the same tools, the same ID, the same, a lot of things that work for Ethereum will also work for those blockchains as well. So that's why we call them EVM compatible, Ethereum virtual machine compatible. So Solana
Okay.
is not EVM compatible. To write smart contract on Solana, you have to learn Rust and a lot of other different things as well. So that's what the difference between those blockchains and EVM compatible. I hope that's clear.
Yes, thank you. But sorry, please, a question. Sorry for drawing you back, please. Like, what's the difference between Web3 and blockchain? Sorry, Web3 and blockchain.
You know, it depends on the term. Okay, in speaking, like blockchain is basically like a decentralized ledger, distributed ledger. It houses records. So when you're talking about a blockchain, now we have examples like the Ethereum blockchain. So the Ethereum blockchain, it's how am I going to explain this? Okay, Web3 is just basically like a progression of the web. So we all know web started from Web 1, maybe in the early 90s or something, when people were creating basic websites where probably just HTML. There was nothing complex. And then with time, new technologies came in. We moved to Web 2. So Web 2 is one where, I mean, people develop complex websites, JavaScript, interactions, and also that's like Web 2. But Web 2 development is still centralized. We still have to use a centralized server to host. We have to use centralized APIs that are subject to a single authority. So with time, the blockchain was introduced. So it's like blockchain. I mean, Web3 is basically like progression of how applications and websites. So this is like the next. I mean, it's possible that maybe very soon. I think maybe this ex Twitter owner Jack Dorsey or something came with something that was called Web 5. So it's basically progression. Currently, when you develop applications on the blockchain, it's called a Web3 application, because now instead of using a centralized server, instead of hosting your applications on a centralized server, you are hosting it on the blockchain. And the blockchain is decentralized. It's not subject to a single authority or a single ownership. It's censorship resistance. So that's what we call Web3. Basically, like developing developing applications that live on the blockchain instead of living on or the kind of servers that were used to. The application lives on the blockchain. It is decentralized. It can be put down or brought down or deleted or something. Once you deploy a smart contract on the blockchain, it's going to be there for, I mean, probably for life. It's going to be on it's on several there are several it's on several systems around the world. So it's impossible for you to say you want to bring it down you want to do some things. So basically, Web3 is like the progression after, is like the next stage of webs of application development after Web2, and it's built by developing applications that live on the blockchain. I hope it's a bit clear like this.
Very, very clear. Very, very clear. Thank you.
Okay. So now we're talking about ARC 20 standard right now. So at Ethereum, the ARC stands for Ethereum Request for Comments. They are technical documents that describe the programming standards in Ethereum. The goal of ARC is to establish convention and facilitate interaction between applications and contracts. Authored by Vitalik Buterin. Vitalik Buterin was one that created Ethereum, and Fabian Vostella in 2015. The ERC20 standard proposes a relatively simple format for fungible. So I'll talk about the ERC. Um, ERCs are like framework, technical standards introduced. Like just so there are always several ERCs. Now the ERC is just like a framework that people invent, that people introduce to the Ethereum blockchain. Is like it's just good. It's meant to guide developers on how to build a certain thing. Now let me give a little bit backstory. When Ethereum was first built, people were building their own tokens. They were building tokens without any standardization. They were using any logic that they want. They were using logic that they wanted for the blockchain to build their own tokens. So it was a bit difficult to interact with. Imagine somebody building a token, and now I want to interact. I'm also building an application. It was difficult to interact with those tokens because everybody was using their own logic to build anything that they want. There was no regulation. I mean, by regulation, I don't mean maybe like censorship or something. I mean, there was no formal guideline on how to build a token. So it was difficult to promote usage and enter. Anyway, so with time, I think that was in 2015. It was the ERC20 was introduced. So the ERC20 standard just introduces a guideline that is going to guide people on how to build a token, a fungible token. So if you are building a fungible token, you have to follow ERC20 standard. And now since there is a standard that people follows, it become easier. I can build an application that will support ERC20 tokens. I don't need to see the code of ERC20 tokens. I don't need to know how it works, but I know that it's going to follow a particular standard. So the ERC20 standard, which you will see very soon, just it contains 6 compulsory functions. So anybody building a token on the Ethereum blockchain, anybody building a fungible token must follow the standards. They must include these 6 functions in their token. Now, because we know these 6 functions will always exist, that means anybody can build a software and applications where people can interact with using their ERC20 token. Because we already know that, okay, once you are interacting with an ERC20 token, the ERC20 token must contain these 6 functions. Of course, after those 6 functions, you can add any logic that you want, but these 6 functions must be there. So that was basically the ERC. That's what ERC20 stands for. So these numbers are just, so this ERC20 is basically like the 20th ERC that was raised. There's an ERC1, ERC2. So people raise these things. People, I mean, it's things, you don't need any special privilege to raise an ERC. You can just tomorrow, you can just decide, okay, this, if we introduce this standard for people to build maybe a particular type of thing, it's going to be helpful. And then you raise, like you create an ERC, then people will review it, go to several reviews. There are a lot of ERCs that didn't really make it out. So anybody can. So this ERC20 is basically like the 20th ERC that was introduced. So this now we'll see more about it now. I know it might be a bit confusing, but if we'll see more. So by following the outline, developers don't need to reinvent the wheel. They can simply build from a base already used throughout the standard. So now we said the ERC20 token is to build fungible token. What are fungible tokens? Since both of you said you've traded or you've done things relating to cryptocurrency, if I want to assume you know what a fungible token is. Am I correct? Are you guys still there?
Yes, I am here. But what if I want to answer? I'm not so sure though, but I think fungible tokens are like, okay, you can own a, what do you call it? A Bitcoin, one BTC, and I also own one BTC, and it's of the same, like the same coin. But
Exactly.
then
Acquire.
NFTs, I think people can only own a share of NFT, like you can't own the original copy. That's what I feel.
No, actually, bro. Your definition of fungible token is correct. Fungible token is one in which all parts of the token are the same. Fungible token or asset are divisible and non-unique. So now let's use the naira as our first example. If I own 10,000 naira and another person elsewhere owns the same 10,000 naira, what we own are the same value. It's not his own 10,000, another person's 10,000 is not more valuable than my own 10,000. That's what we call being fungible. They are of owning a single unit of a particular currency is the same thing, is of the same value as owning any of owning a single unit. So like the units have the same values. There is no now when we are talking about NFTs are not fungible because now a contract NFTs from the same contract, they are not fungible because hence from same contract, some NFTs will be more valuable, some will be less valuable. So I can't say because I own a particular NFT of ID or maybe ID 10 and then somebody else that owns the same NFT of ID 5 or 6. I can't. They are definitely not the same thing. His own might be more valuable than mine, and those values are usually determined by the rarity plus some other factors. So another person's NFT, the same NFTs belonging to the same contract. Another person's NFT might be more valuable than mine. That's why in NFTs we have IDs. So for a particular contract, each NFTs will have its own ID. So we use those IDs to separate the NFTs to differentiate the NFTs. But when we're talking about fungible tokens, they are of the same value. If I own 10 USDT, it's the same value as another person that owns 10 USDT. There is no difference. His own USDT is not more valuable or less valuable than mine. So that means we can easily exchange. I can give him my own 10 USDT and he gives me back his own 10 USDT, and there is no difference. Nobody is feeling shortchanged or anything. That's what we call fungible tokens. So the same fiat currencies like naira, dollars, they are all fungible because they all have the same value and they are divisible and they are unique. All the parts are the same. I think you should understand. So examples of fungible tokens include USDT, which is a stable coin, the Link token, the Aave, RAT Ether, DAI, and Mana. So I hope the explanation is clear enough.
Yes, thank you. It's clear.
Okay, so something like we're talking about lands. Are you able to say land is a fungible token or not?
I will say it is a non fungible token because a plot of land in Lagos is different from a plot of land in Ife.
Exactly. Mhm. Yeah, exactly. That's what we mean by that's why if you even see applications where they are trying to maybe like they are trying to create marketplaces for lands where you can trade lands on blockchain, they will always represent each land with a NFT because they are different. You can't represent a land with an ERC20 token because land is not fungible while an ERC20 token is fungible. So let's move on to the next. Yeah, to be ERC20 compliance, your contract must include six mandatory rules: start supply, balance of, transfer from, approve. So these are the six. So let me just quickly show you guys the ERC20 guideline so that you see what I'm talking about. So it's publicly accessible. There is really no. Yeah, so this is the EIP. So whenever a new guideline is proposed, is always an ERC. But after it has been confirmed and introduced to the Ethereum blockchain, then it becomes an EIP. So this ER20 standard, ERC20 standard, token standard, author Fabian Wisteria, Vitalik Buterin. It was created 2015. That's November 19, 2015. So let me just take it. So this is token standard. The following standard allows for the implementation of a standard API for tokens using smart contracts. So you can just check through it, or maybe after the class, can but it just specifies the function that an a fungible token must implement. So there are six compulsory functions and three optional functions. But those three optional functions are actually very useful. So most people, I don't think I've seen an Yasuo token that doesn't include these three optional functions. So the optional functions are name, symbols, decimals, while the compulsory functions, total supply, balance of, transfer from, approve, allowance, and the events. So I would explain what events are later on. Event transfer, event approve. So let me just send the link to the chat in case you want to check it out later. So here's the standard. So let's go back to. So first must include six compulsory functions, total supply, balance of. So yeah, this from the name we can at least infer what these functions do. But of course we would explain them more in details. Yeah, let's start. So let's start with the optional. So how I want this thing to go is I will explain a particular function and then I'll write the code to implement it so that you can so explain first, explain the function, then write the code to implement it. Is that okay?
Yes, it is. Thanks.
Okay. So we build the three optional functions first: name, symbol, and decimal. The optional functions are going to be included, but they can make your expensive is put here. So the name basically allows us to introduce the name for our token. Now, tokens like USDT, the name is probably Theta. I'm not 100% sure, but it's probably Theta. So, basically, the name of your token, of course, you have to give your token name. There is no way you're going to create a token and say you're not going to add a name to it. And then symbols. So, for USDT now, the symbol is the USDT. So that's the symbols are what we're when you're using exchanges, you mostly because the names are always long. At least you see a lot of names that are long. That's why most times when your token is always represented with the symbol because those ones are short and it's easier to use. So we have the name of the token, the symbol. The symbol is always a short form of the name. If maybe like three letters or four letters. And now decimals. Okay, for decimals, let me just explain it when I'm implementing the functions. So tokens are used as currency. Yeah, so we'll be implementing the name, symbol, and decimal function. So I'll be using Remix. Remix is an online ID. For those that were in the previous classes or maybe watched the videos, Remix was used as well. So it's just an online ID where you can write solidity, compile solidity, deploy your contract on a testnet. So let's create a new file. Probably just call the name AS20. So .sol is an extension for Solidity, for a Solidity contract. The same way you have .ts for JavaScript. So just .sol is like the extension. So when you're creating a smart contract with Solidity, the first step is you have to specify the version of Solidity that you're using because Solidity is always improving. Currently, the version is maybe 0. Latest version that was released maybe like a week or 2 weeks ago. I think 0.8 points, maybe 1.9 or something. So there are always new versions of Solidity being released. So you have to specify which version you are using when you are writing your code. So that will allow the compiler to know how to compile the code and how to like run the functions in the code. So this one will be using version 0.8.0. So this little symbol before this version 8, before this 0.8.0 means this smart contract can be compiled by any solidity version from 0.8.0 to from 0.8.0. Now it can be compiled by 0.9.0 and it can be compiled by 0.0. Can be compiled by 0.7.0. So basically this means 0.8.0 to any. So once when they are releasing solidity versions, the first it's always going from there is always a it's always going from 0.8. Now, when it started, I think it started from maybe 0.1.0 or something. So, when they release a major version, something like this 0.8.0 is always a major version. It's going to contain a lot of changes and all. But after releasing the major version, they will keep releasing some minor updates. So, those minor updates will be represented by 0.8.1. 0.8.2, 0.8.3. So the next major version after 0.8.0 is going to be 0.9.0. That one doesn't exist yet. So this little symbol means this symbol means this contract can be compiled by Solidity version 0.8.0 up to 0.8.x. The x can be any number. It depends on well whatever release that they make. It can get up to like 0.8.20 or 0.8.15 or something. So whenever 0.9.0 is released, then this contract will not be compilable by that 0.9.0 solidity version. So I guess that should be clear. So this is always the first thing to do. This SPDS license identifier is actually it just specifies how the code can be used, more like a license. So that in some there are some codes because most times smart contract codes are always open source. Anybody can see it on the chain. So this license just specifies if the code is reusable or if you have to like request for permission to use any part of the code or something. So so the next thing is how to create a name for our contract, how to create a contract and create a name. So probably just go for the same ERC20. Probably just go for the same ERC20. So the name can be anything that you want. The contract and then the contract name. And next, this is called the basis. So the name of our contract is ERC20. Now we said we want to build out three functions first. So the name of the contract, the symbol, and the decimal. So we'll start by using the state variables to load. Yeah. So let's start. The name is going to be a string. So just do something like so this is a state these are called state variables in Solidity. The string, so we are basically creating a variable named the name of the variable is name. That's going to be the name of our ERC20 token. And the type is a string, so it is of type string. So let's make it private. So basically private variable is if we've used other languages maybe like Java or something, it's basically the same thing. So this variable can only be accessed inside this contract. You can't access it outside. Even contracts that you inherit from this particular contract, you can't access this variable from it. We have different types of variables in Solidity. We have the private, we have the public, internal. Yeah, I think we have those three: private, public, and internal. So this variable is private, which means we can only use it inside this smart contract. Once we are outside the smart contract, even if we are inheriting from this contract, we still can't access the name variable. So after that, we create another variable towards the symbol. And then another one to hold the decimal. Now the decimal is okay. Let's finish up this name and symbol first. So there's something called constructor in Solidity. Once again, if you've used other languages, the concept of the constructor is the same thing. It's just a language, it's just a function that is used to initialize this contract. The constructor will run only once when we are deploying the contract. And once you deploy the contract, you can't run this constructor again. So it's just used to initialize. Right now, I'm going to use the constructor to initialize this name and symbol. So let's see. So the constructor is basically a function, but a function that can only run once when you are deploying the contracts on the chain. So the constructor is going to take two arguments. So that means when we are deploying the contract, inside the constructor we pass these two variables, the name and the symbol. So inside we just set these two arguments. We set these two arguments to the storage to the state variable that we've created up here. So we just do something like name. So this name is this state variable that we created up here. So we just do name is equal to underscore name. Yeah. So we just do name is equal to underscore name. So basically this name argument, we're setting this underscore name argument to the state variable that we created here, which is called name. That's the first step. We'll do the same thing for the symbol also. Of course, you can use any names that you like. You can use anything. If you want to hold, you can use this token name, token symbol. You can use any name that you like for these things. So far, is this contract clear enough? Can I move on, or is there any question?
Please, like I'm actually getting where we can use different names. Like, can you use Ayola as the token name so that we're able to get? Because I think I don't know which one is the label, the
Okay,
tag, and which one is the yeah.
okay. I guess this is another. So can you suggest any name that we can use?
Your name is okay, Ayola.
Let's use let's use something is let's see let's use token name instead. Let's use token name and token symbol. So I have to change this to token symbol. So is this clear enough?
Yes, it is there.
Okay, so these are just arguments. Basically, once we leave this constructor function, we can't access these arguments again. So that's why once we pass them to this constructor, just set them to this state. This state variable can be accessed anywhere in the contract. As long as we set this contract, it can be accessed. That's why we just set this argument to the state variables. So these are the names. So that means after deploying the contract, we already have our names and symbol. So we just create a function that so if I want to know the name of the contract, I can just call that function and the function will return the name. Same thing if I want to look at the symbol, I can call the function and it will return the symbol for me. So we'll call it function name. It's not going to take any arguments. So when I'm creating so this place will contain all the arguments for our function, but it's not going to take any arguments because we just want it to return the name of the contract. So in Solidity, we have this public basically means this function can be accessed anywhere. It can be accessed inside the contract, outside the contract. It can be accessed anywhere. That's what public function means. So yeah, we can make a function private. So it's private basically holds the same meaning as the private for this state variable. We want the function is private. Outside this contract, you can't access it again. So we have private, we have public, we have external, we have internal. So we'd see as we go on with the contract, probably implement other types of functions as well. So currently we make this function public, and we're going to define the return type. So how do we specify the return type? We add this keyword returns and we put in the type that we want it to return. So we're returning the name, and the name is of which type? The name is a string. So we can just add string, and also because it's a string and strings are reference type, we have to add the data type. So most times the data type is always going to be memory. So we just add the string and the data type, and then we are just going to return name, public name, function returns. Okay, okay, okay. This state variable and this function, they have the same name, and they're not meant to have the same name. So I'll just change this one a bit. Let's add the underscore here. So we'll do the same. We'll change the values here. So what's the demo about? Okay, so this is just a warning. It's just warning us about the gas, which for now. Oh yeah. So we have this function states mutability, and we should make it view. So when we make it view, so view just means when we call this function, it's it's not going to. This might be a little bit complex to understand, but like when we make a function view, it just means this function is not changing any. These are the state variables that we currently have. We have those two values as state variables. So when we call a function, when we add view, it means this function is going to access these state variables, but it's not going to change them. Probably see more examples with time. So that's what view function means. It's going to access the variable. It's going to access a state variable, but it's not going to change any state variable. So we add the view and then return string memory. So like this, we have our function. So once we deploy the contract, we can call the name and we return it's going to return the name of our token. Let's create another function to get the symbol also. Same thing, almost the same thing as the one to get the name. Apart from the fact that we're only going to return different variables. So same thing. String maybe. So for every line of code in Solidity, we have to end it with this semicolon. If not, we are going to get an error. So now we have these two functions. The function name returns the name of our token. The function symbol returns the symbol of our token. That was the same thing that was specified in the ERC20 implementation. Name returns the name of the token and symbol. So it means so far I hope these two functions that we have written is clear enough.
Yes, it is.
Okay. So now let's go
But
to
sorry, like,
okay.
have we declared the symbol for our token?
Like have you assigned any value to the variable, right?
Yes, yes, yes.
Cool. For now we haven't currently. But whenever we are because the constructor is the one taking the arguments, is the one taking this name and symbol value. That means and it's when we are deploying the construct it's when we are deploying the contract that we are going to add this argument. So they are going to see it whenever we are deploying the contract, we are going to add this we are going to add the name and our symbol. So that's why inside the constructor we've already set this name here to whatever value we are passing in the constructor and set this symbol also to whatever symbol. So for now we haven't added anything yet, but you see it when we
Okay,
add
okay.
So you can as well add it like this also. Maybe name is equal to blockchain OAU blockchain OAU. You can as well add it here if you want actually, but it's always better to add it in the constructor than just like so. You can as well add it here. So if you add it here like this, you don't need to like add anything in the constructor again, and then the function name will return this one, the symbol to return. So you can as well do that, but let's just stick to our constructor implementation for now. So now let's go to symbol. Let's go to decimals. Decimals is the third optional function. So when we're talking about decimals, um, let's use eta. You know, as much as eta is not an ERC20 token, but the concept of decimal is just ERC20 token looking to like emulate a feature of eta. I believe you all know what eta means, right?
Zeta, is
Can you
it
guys see me?
TRC like throne?
Okay. Are you saying something?
Yeah, like I said, is it throne? Do you mean Tita?
No. I mean Ether, like the Ethereum itself, like the currency, the Ethereum currency, not Tether. Tether is USDT. Okay, so our zone, you know what Ether is, but do you guys know what BNB is?
Yes, sir.
Yes, sir.
Okay, okay. So Ether is the native currency for blockchain for Ethereum blockchain. So when we deploy our contracts now, we're going to be paying gases with we're going to be paying the gas fee with Ether. You can only use Ether to pay your gas fee on the Ethereum blockchain. You can't pay your gas fee with USDT, although there's something called account abstraction that is coming to change that. But for now, we just stick to that traditional knowledge. So for now, you can only pay. So that's like one of the biggest use cases for native tokens. So this decimal now, okay, since let's just use like USDT as an example. Then, if you own one USDT like this, what is actually what the smart contract actually knows is that the decimal of USDT is 18. Is 18. That's the decimal for USDT. So the outside world in my what you own, if you own one USDT, what the contract is actually storing is 10 raised to power 18. That's what the contract is actually storing. So like one USDT is equal to 10 raised to power, because the decimals for USDT is 18. Now why can't they just store one? Now in solidity we can't store floating points, we can't store floating numbers. So we can't store decimal numbers, we can only store whole numbers. Now for somebody that owns, that means there's no way for somebody to own 1.5 USDT or 2 point something USDT or 10 points. That means if there was no concept of decimals, anybody holding USDT or any other token or even Ether or anything must own a whole number. You can't own decimals. And now imagine somebody owns one USDT like this, and you want to transfer half of it to another person. That means you'll be transferring 0.5, but since Solidity and smart contracts cannot hold decimal numbers, that will be impossible to transfer. That means you'll be stuck to transferring whole numbers. You'll be stuck to transfer, you'll not be able to transfer floating points. So that's why there is something called decimals. Now, when you just said owning one USDT is the same thing. Like on the contract, what the smart contract is actually storing is 10 exponential 18 USDT. I mean 10 raised to power 18. So one that means if you are sending, imagine you are sending half like this. If you are sending half of your one USDT, what the contract you have to actually be sending is going to be that's going to be 0.5 times 10 exponential 18. So when you do this, that means you end up having an whole number. You are probably have five with 17 zeros. So because of that, that means you can even send maybe like 0.00001 of your token, because once it gets to the contract, it's like going to be multiplied by like 10 raised power 18. So that means at the end of the day, even if what you are sending, what you think you are sending, even if it's a decimal point, once it gets to the smart contract is going to be sending a whole number of value. It's not going to be decimal points. Is it a bit clear?
Yes, it is.
So it's something similar to say maybe Naira and Kobo. What you are seeing, imagine having a system maybe like our banks. I'm not sure of how the bank stores the money, but imagine maybe like what you sell on bank app, what you spend, you are spending Naira. But like inside the bank, the calculation that goes on is actually converting all your money to Kobo. So when you are seeing 15 Naira outside, what the bank is actually storing for you is that's going to be 5,000 Kobo, right? So on the outside, you are seeing 15 Naira, but what the bank is holding is 5,000 Kobo. So that's basically the same thing, same concept. What you are seeing outside is going to be like one USDT, one Ether or something. But on the contract, when the contract is storing it as is 1 times 10 raised to power 18. So it's something similar. So that's but most tokens actually they use 18 decimals. But there are some tokens, it's not like a must for a token to use 18 decimal. USDC, that's Circle's USDC. It uses just 6 decimal. That means when you own one USDC, then what the contract is actually storing is that's one with 6 zeros. So that's what USDC uses just 6 decimals, but most tokens actually use 18 decimals. So I hope it's a bit clear.
Yes, I think so.
So we just implement let's do something function, name it decimal. Is it decimal or decimals? Okay, so it's decimal. Same thing, it won't take any arguments. It's public. Our time is really going. This past 7 minutes. Public view. So because decimal is going to be an integer, right? So we won't be returning string this time around. We'll be returning uint. So uint is used to hold. So let's do uint 256 actually. So uint 256, they are used to hold the uint. The full meaning is unsigned integer. So these uints cannot hold negative number, can only hold positive numbers, and it is 256 bits. 256 bits, that's 32 bytes. That means it can be that the maximum number that the uint 256 can hold, and the minimum number. There are different uints. There is uint 8. In fact, for this decimal, the unit 8 is always like the most appropriate actually, because unit 8 is an only hold from that's 0 to 2 to power 6. I think that 64 or 128. So and there's no way, I don't think there's no way our decimal value can be more than 128. But unit 56 is actually the most used unit, and that's what you see. You see that's the commonly used unit. So we just use it actually. So we are returning a unit 56 value. So we just return 18. Now can as well do now, in fact, because this one, now if you notice inside this function we're accessing state variable, we're accessing it, but we're not changing it, we are not setting any state variable, we're not creating. Now this constructor is changing state variable, is changing the name here, which is empty, is setting it to this token name that we're passing. So this one is accessing and changing a state variable. This function name is only accessing a state variable, is not changing any value. The same thing here also. So that's why these ones are view, and this one will not even hold anything at all. It won't take any view or pure or anything, because it's accessing state variable and it's also changing it. So it will not even take. So but this one that is accessing it is taking view. Now this decimal, if you notice, I'm turning 18 straight. So it doesn't even need to like access any state variable. Now this one is going to take pure. So these things like things are called function, mutability or something. Public, private, internal, external, those ones are called public function visibilities. So this function is pure because it's not even accessing any state variable. Now we can as well do this one also, maybe like create a state variable, string, decimals, and return the decimal here. So if we were to do that, then this function will become view. But I just started to just so that we can see another a different type of function implementation. So this one will return 18 straight. So once you check your decimal, it will return 18. So now we've implemented the three optional functions. So before I proceed, any question, anything?
Not yet, sir.
Okay, that's cool. So we've implemented these three variables, these three functions. I mean, the function to return our name, the token name, the function to return the token symbol, and the function to return the token decimal. So let's move. Our time is really going. So total supply, total supply. Yeah. So when called by user, the function returns the total supply of tokens. So it's just basically like total supply of a token, like the total amount of that token that currently exists. Imagine you create a token, maybe after creating it, you maybe like you created 1000 raised to power 18 tokens. So that's the number that exists. So when you call total supply, that means when you call a total supply function, you can get the exact supply of that token that exists. Now it's possible for some tokens to implement the mint function. So mint, when you mint, it's just like you're creating new tokens. So if a token implements that mint function, that means every time you mint, total supply will increase because you are minting. Now, if you are transferring a token, you are just transferring from somebody to another person. So you are not creating new token. It's the same token as existed before they are transferring. But for mint, you are basically creating new token. So when you create new tokens, the total supply will increase. And there's something called burn, like the opposite of mint. When you burn, you are destroying tokens. So when you destroy tokens, when you burn tokens, and the total supply will reduce. So total supply just holds the supply, the number of that tokens that currently exists. So let's implement that one to sharp. So we have, so let's create a variable that will hold total supply is going to be an integer. So we have units total supply. Let's just so let's add a function now this total supply. Okay, let's add a function. So almost the same thing as the name and symbol functions, but the only difference is this one returns an integer instead of a string. Return total supply. So there are different logics that we can use for something like total supply. Currently total supply is zero. If we deploy this control like this, our total supply is going to be zero. But let's do something here. Eh? Let's do something. Okay, we'll do something. We'll do it later on. Once we introduce the balance of function. Okay. So the next function to implement is balance of. So this balance of is basically what the name is. When you call the balance, pass in an address when you're calling the function, and it's going to return the balance of that address. Basically, the amount of the token that this address owner is holding. If this address does not own any token, then it's going to return zero. So You can check the balance for any address. I can for any token, any ERC token, I can check the balance for any address whatsoever. It doesn't have to be my own address, it can be anybody's address. I can check the balance. That's why inside the function, that's why inside the function they are passing this address. So it's going to return the balance of this particular address. So we want to return the balance of this particular address. Unlike total supply, remember when we implemented total supply now we didn't pass anything as argument. But balance will take an argument and an address argument. When called it returns the balance of that address token not doing. Remember that account on the TR method can public, so you can query any user balance provided you know the address. So let's implement that one too. So we have to also define a state variable that let's make this one to private. Now there's something about public okay let me show you. Let me just show you. There's something about public variables. When you make a state variable public, like I just made this one public, solidity automatically creates a getter function for you. Now these variables are private, right? So the only way we can access them outside the smart contract is because I created the function. Now when I call this function, it's going to return this. When I call this function, it's going to return this. If these functions were not there, then I won't be outside the smart contracts. I won't be able to access this name and the symbol variables. But if I make a variable public, a state variable public, automatically I can access it. I don't have to create any function like this to access it outside the smart contract. Something like this will be created automatically. So let me just deploy this contract and just show you how that one works. So avoid this. So I'm just going to it has already been compiled. Okay, I'm just going to compile it. Yeah, so I'm going to compile and deploy. So this is at this point that I'm going to add this argument that I wrote here. So as you can see, this space, that's what I'm going to like write the token name and the token symbol. So let's make the name maybe blockchain OU token or something. Blockchain blockchain OAU token. Let's probably make this as DC or something. Yeah, so let's just make that the name and the symbol. Okay, it has to be is a string, so it has to be like quotes. Oh, I don't even think that's necessary. Let me just so the symbol. Let's just make it maybe BCT. BCT. And let's deploy. Yeah, it has been deployed. So Remix provides a very fast blockchain for us that we can easily. So this blockchain is not the real thing. It's not even a test net. Outside this my Remix instance, outside this Remix instance, I can't access this blockchain anywhere else. So it's just like a temporary, but it's very fast. We can use it to like simulate how the real blockchain works. So I've deployed it on the blockchain that Remix provides for us. So after deploying it, this is the address for the smart contract. Now you can see this is our name, the name that we created here. Record the name, we get back this PCOU token, record the symbol, get back this PCT. Now notice, even though I didn't create any function, I created now okay. Notice this function I created is total supply. This is it. But this one is underscore total supply, and this is it. So basically, in fact, let me just redeploy to make it clear. Now another thing about smart contracts are they are immutable. So now that I've deployed this one, I can't change anything on it. I commented out this particular code, but I have to redeploy it to see what I did. As I remove this code, it's not going to reflect because that one has gone, that one has been deployed, it cannot be changed again. So if I want to change something, I've changed it now, I have to still go and deploy the contract again. So let's do that quickly. Oh man, I have to type this in. Okay, so Mm, so let me deploy it again. Yeah. So now you can see the change. This is the name, this is the symbol. But even though I didn't create any function for this total supply, like I call it, it's going to return zero because we haven't assigned anything to it yet. So that's what it will make a function public. That's basically what it does. It is accessible from, I mean, it will make a state variable public. It is accessible from anywhere, and a function is automatically created for us to get that variable back. That's what public does. So if we were to make this name and symbol, if we were to make them public also, then there's no need for all these functions again. But because I want to build them, I want to build them specifically so that we can see how it works. That's why I just had to add all these ones. So let's go back to our code. So of course let me make this one private back so that we can, I want us to see everything clearly. So avoid private and comment out this. Please guys, if you got any question, please ask your questions. No matter what, how you take it, ask your questions. And if you think something is not clear enough, please let me know so that I can explain. So that's for the total supply also. Total supply function to install. Now it is not technically done. We have still add some things because currently total supply is zero. So I will still add some things that will make it return a real value. But for now, let's okay. So we're talking about the balance of. I think yeah, we're about to even implement the balance of function. So we have to create another state variable that's going to hold the balance. But this time around, we'll be using a mapping because we want a way that we can assign each addresses. We want a way we can assign each address. I mean, each address to their own balance. So all these ones, we could use a single state variable for them because the name is the same, the symbol is the same, that supply is the same. But this one, the balance of a particular address is not the same as the balance of another address. So we can't just hold it using maybe like a unit balance. That's not going to work. We need something that can hold a key value pair. Something similar to maybe an object in JavaScript or a dictionary in Python. At least I think that's like the clearest. So when we're defining the mapping is a key value pair. So it's we're basically mapping an address to a uint. This uint is the balance. So when we call, let's name it balances underscore. So basically this mapping maps each address to their balance. The balance is one in uint. So that means when we call balances of any address, let's just represent this is not an address looks like, but if you call balances of an address like this, so it's going to return this. So balances of this address is going to return the uint value for us. So I hope that's clear. So balances. Now let's create a balance of function. Now once again, this one is private. It's going to be internal by default. Let's add private so that it can be clear. So once again, this value is not can be accessed outside the smart contract. So we have to create a function to access it. So let's do that sharp. Getting there, we should finish in our case. So let's call the name of the function balance of So this time around, this one is going to take an address argument. Going to take an address argument and it's going to return something. So of course it's public and it's also view and it's going to return something. It's going to return something. It's going to return an integer, which is a uint 256. It's going to return a uint 256. I like it's an error. I'm not expected. get function balance of records address. Who would use 256? Okay, let's see public view. Alright, so now we're going to return balances of this address to our person. So this will return, it's going to call this mapping. So the balances of this address. So it's going to return a unit for us. This unit is the same thing as unit 256. We use them interchangeably. So calling these balances with any address will return the balance of that particular address, which is a unit. So I don't really get, where am I getting an error here? Expected cover what codes address. I don't know what's going on. This public view returns. Six public view returns. Okay, address is what do we call? It's a keyword, and that's why. So it can't. I can't use the address. So I'll just. So I guess now that way like this. Oh, that's the problem. Oh, the argument to balance off is meant to be an address. So I'm passing an address. We want to get the balance of a particular address. So I'm meant to pass in an address type, not an integer. So that's the reason for the error. So like this, you get the balance. So this one, once you pass in any address, is going to return the balance of that particular address for us. So let's move on. If anybody else has any question, please ask. I'll just answer. That's balance off. Now let's go to this transfer. This kind of transfer just does what it says, because this is the function signature transfer to an add. So this address too is like the address. So when I call this transfer function, whoever is calling it, whichever address is calling it, is the one transferring the token. So if I call the transfer function, it's going to is my own address. I'm transferring from my address to this to the address that is passed here as the two, and this is the value that I'm transferring. So I'm transferring this amount. This value is the amount of the token I'm transferring, and I'm transferring it to this address, and it's public. So let's just so it transfers tokens from one user to another. So here you provide the address you want to send to and the amount. So this is the amount to transfer, and this is the address I are transferring to. Yeah, and then we are going to emit an event. So let's write that one fast structure function. I want to like increase our pace because of the time. Function transfer the address to and the units 256 value. So this one is not really, although it returns bool actually. It's not meant to return bool. Yeah, it returns bool. But that's not really important. That's not really important. Let's leave it for now. It's meant to be it's a public function. Yeah. So basically, can anybody just explain, like when you transfer, what are the changes that are meant to happen? I mean, even if you are even if it's normal, if you are transferring naira or something, what are there are two major changes that are meant to happen whenever you transfer. Can anybody just maybe like tell me what those two changes are?
The debit on the sender and the credit on the receiver side.
Exactly. So when you call transfer, um, the first thing I would do is actually check that. Now, there is something called msg.sender. So let's just do address sender. So this sender is like the person send. So this sender is the person calling this transfer. And how do you get the person calling this transfer? There is a global variable called msg.sender. So this msg.sender is going to return whoever it is that called, which address it is that called this function. So if my address calls this transfer function, msg.sender is going to return my address. It's not going to return this address to when it's return the address that I actually called this function. So let's just assign it to address sender. So because we've gotten this, so this person calling the transfer function. So let's check if this sender actually has up to the amount that I want to send. I mean, if I have 1,000 in my account, I can't send 2,000, right? I can only send 1,000 and below. So there's a way we check for such condition in solidity, so that if the condition is not met, the transaction is going to be VAT. So we can use require. There also something called custom errors also, but let's just go with require for now. So require, so we're requiring that now we want to check the balance of this sender. We want to check that it is greater than or equal to this value. And how do we do that? We access this our balances variable. You can as well call this function also. You can as well do require the balance of sender, because it's going to return the same thing. But let's just do balances of sender. So require that the balances, I mean, it's just what it the same expression, the same thing it means. So require that balances of sender is greater than or equal to the value that this person wants to send. If it is not, throw an error with this error message. Let's just make the name insufficient amount. So this line get the sender of the transaction, and then we require that this sender actually has up to this amount that I want to send. If it doesn't, then this transaction will fail. The transaction will fail with this error, insufficient amount. Yeah. So that means if this line passes without the contract, without the transaction reverting, that means the person has up to this value or even more than that. So after that, so the next thing will just be balance of, let's do balances of sender minus equal to, okay, let me just make it so that it's clear to everyone. It's equal to okay, balances of sender minus value, and then now this is the person that we are sending the money to, right? So his own balance is meant to increase. So we do balances of 2 is equal to balances of 2 this time around plus value. And that is all our transfer function does. It checks that the sender and the person sending has up to the amount that is sending. It removes the amount from the sender's balance and then adds it to the recipient's balance, and that's all. That's what the transfer function does. I hope these things are becoming clearer now, not more confusing. So move on to the next function. Yeah, and it's meant to emit an event. So events are just things that alert the outside world that something has happened. So we want a way whereby if anybody transfers, so if we deploy this contract, we probably want, when anybody transfers, we probably want to know. I don't want to have to be checking the smart contract logs or something to know when somebody has transferred. So when we create an event, it's just an event, it's going to fire whenever this transfer. So we can create an event for this transfer function. So we just call it event transfer. So it's going to emit 3 variables: this sender, the sender, the recipients. Let's just do the two. No, the sender is meant to be is an address, not a unit. And the address too. So I think we have to like follow this. That's why it's a standard. We have to follow. I think it's not. It's must require the transfer event. Yeah. So the name has to be this. In fact, let me just copy it from this place. So I can't use any name that I want. Because I'm following this standard like this. The same thing about this function that we're creating. It has to be the same name that was specified here. I can't just decide to use. That's why it is standard, and that's why it makes developing an ERC20 token. It promotes the use cases because we do know that this ERC20 token will contain these particular functions and these events and all. So it's easy to like interact with any token deployed. So let's make it. Yeah. So the name of the event is transfer and it's emitting three variables. It's going to emit the sender, whoever is sending anything, and the recipient. The recipient is the tool, and then the amount that is being sent. So let me to the semicolon. And then so after we've done this whole transfer thing, we just emit the event. I'm going to emit the event. So the sender, so who is the sender? That's the same variable that we have on line 40. That's the sender one. And then the next one is the recipient, which is this address too that's coming from the argument. Same thing. Yeah, the recipient. And then the value that is being sent. So that means if anytime any transfer occurs, an event is going to be emitted, it's going to be fired. So it's something that you can listen to. You can write the script using JavaScript that will listen. So anytime this transfer event occurs, it's going to know and it's going to do. You can program it to do anything that you want. Maybe send the mail, do something, change something on the front end. So you can also on your front end, you might want to know once any transfer occurs so that you can calculate because of course when the transfer occurs, then the balances of two people would have changed, both the sender and the two. So by emitting an event, you can listen to that event. So once you listen to the event, you can just change like you calculate the balances of these two addresses involved so that you can see everything in real time. So that's what the transfer function does. Now let's move on. Battery is running out. Let's move on to the approve. So approve, allowance, and transfer form are actually very similar. Not like similar, but like they are related. So from what I've explained regarding this transfer function like this, you get that I can only transfer from my own address. I can't transfer from any other person's address. It can only be my address alone because this sender here is getting the sender from message.sender and for me to be message.sender that means I own an address and I have the private key to that address because I have to start this transaction with the private key. So I can't there is no way this message.sender can give another person's address apart from whoever is calling the transfer. But to increase the use cases of ERC20 tokens is always there will be situations or scenarios where we want like amount to transfer token for another on behalf of another person, which is amount like so instead of amount to transfer, but instead of transferring from my own address, amount to transfer from another person's address. But you would say if that was possible, then that means anybody can just transfer anybody's token, which won't really make sense, right? So that's why we have this approve first. Now let me use this. Okay, imagine maybe like my dad is traveling like this and he has money in his account, but for whatever reason he doesn't want to transfer the money and he knows I'm going to need money. He knows I might need money, but he doesn't want to transfer the money to me for whatever reason. And then he goes to the bank manager of his bank and tells the bank that okay, this boy, I want him, he can spend out of the money in my account, he can spend this particular amount. Let's say 20,000. So he goes to the bank manager and he tells them, yeah, this boy can spend 20,000 of my balance. that money is still in my dad's account. It's not in my account. But he has gone to the bank to tell them I can spend a particular amount from his account. So that's basically what approve means. When you call approve, you're calling it with two arguments, the spender and the value. I basically telling the token contract that I want this address, that is the spender, to be able to spend this particular amount from my own balance. The person may spend it, the person may not spend it. That balance is still in my own token. It's still in my own balance. I haven't sent it to him yet. But if he wants to spend it, because I've approved it, because I've approved this spender, that means this spender has the ability to transfer my token. So that's basically what approve does. Approve is another using function. With this function, you can limit the number of tokens. So you can set the number of tokens that you want. It's not like the person can just spend all your tokens. The person can spend only up to whatever it is that you set here. So you can limit without the underscore, blah 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 blah. So when code approve triggers the approval event. So once you approve somebody with this allowance, you can check. Now once let's assume somebody approved me. Let's assume I approve somebody to spend like 10 of my tokens. Now if person calls this allowance function using my own address as the owner and his own address as the spender, it's going to return 10. So it basically just returns the allowance, it just returns the allowance of this owner to this spender. So basically whatever was approved, if nothing was approved, then it will return 0. So if something has been, if I've approved somebody to spend my token, if the person calls allowance using my address as the first argument and his address as the spender, is going to return the amount of token that I approved him to transfer. But how does this person transfer exactly? Because you can't use the transfer function. Because when you use this transfer function, it's going to transfer from your own address. You can't set, there's no way you can set another person's address as this sender when you're calling the transfer. And that's why the transfer form exists. So with this transfer form, I can send token from another person. If you notice, when transfer takes two arguments, the to and the value, but this transfer form takes three arguments. It takes the form, to, and value arguments. Those are the three. So now I can specify that instead of sending from mh.sender that we did here, instead of sending from this mh.sender, now it's going to transfer from this form, then it's going to transfer this value from this form address. It's going to transfer it to this to address. That's the difference between transfer form and transfer. When I use transfer function, I'm transferring from my own address, But this one transfer from, I can transfer from anybody's address. But this transfer form will only go through if if this address that I'm transferring from has approved my own address to transfer its token. So this transfer form is basically the same thing as me now going to that bank and telling them, yes, I want to transfer, but this time around, not from my own address. I want to transfer from my dad's address. And because my dad has told them to allow me transfer from his address, that means they would allow me transfer. But of course, I can only transfer. Hey guys, sorry I went off. My network went off suddenly. So, can you guys hear me now?
Yes, I can.
Okay, so let me just share my screen. So I think I was talking about this transfer form. So I was saying, okay, yeah. So this you can really transfer form when the person has approved. So I mean, it don't make sense if I can just transfer anybody's token without the person's permission, right? It doesn't make sense. So this the process of approving is like me being granted the permission. So you can only transfer form when the person has granted you that permission to transfer. So I don't know, is the explanation clear or there's any question?
So it's clear.
Okay, that's cool. So let's implement those let's implement those functions as well. So that's like maybe like the most complex out of the whole ERC20 standard. So you can see creating a token is not, and this is almost the same logic that tokens that have like big values, tokens that are really used. If you check the smart contract code for USDT or USDC or something, it's going to be very similar to what we're building. Maybe there might be like some 2 or 3 extra functions, but basically it's going to be just this thing. So now let's implement the transfer form. Okay, first of all, let's create let's create a mapping to hold. Now this time, if you want to create a mapping, the mapping will hold. Okay, now for my address like this, the mapping is going to hold all the addresses that I have approved to transfer my token with the amount that I approved them to transfer. So it's going to be a nested mapping because we need 3 values for this mapping. We need whoever is approving it, the approver, whoever is being approved, that's the spender, and then finally the amount that the person is being approved. So we need 3 values. That's why we'll be creating a nested mappings because we can't create two a normal mapping like the one that is here because this time around we don't need 2 values but 3 values. And this is how you create a nested mapping in Solidity. Mapping of address to it's allowance now, so it's going to be units. 256. And we're going to call it, let's make it private as well. We're going to call it, what's the name? I'm going to call it as allowance or something. What's the name? Is there any name specified? Okay, let's call it allowances. Yeah, so this is the address of whoever is approving it. This is the address that is being approved, and this is the amount that the person is being approved to transfer. So now, so this is the created is a state variable to hold these allowances. So let's just create a function. Now let's create this approve function. Let's create this approve function. The function you call to approve somebody to spend your token. So let's name this approve, right? Name this approve. Yes, approve. So let me say approve. Now it's going to take in 2 arguments. The first one is an address. So let's call the name is spender. So the person that is spending another person's token. And then the value, which is going to be a u int 256. Yeah, 256 value. Doesn't return anything, but let's have to make it public. So that anybody can call it. If it's not public, you won't be able to call it outside the smart contract. You won't be able to call it from another contract, or maybe like if you're writing a script or something, you can only call public functions. So now, how are we going to get the person approving this spender? We're going to get it once again using this image.sender. So whoever is calling, if I want somebody to spend my token, I will call this approve using my own address and set this spender and value. So we just set a value. We're going to call the allowances state variable. In fact, let me put it up so that you can easily see the allowances state variable that we're going to access. So this is it's basically we're going to set this allowance. I'm just going to call allowances of msg.sender. So that's the first address, msg.sender, and the next one is going to be this spender. I'm now going to set it to this value that is coming in. So this address is the msg.sender, that's person approving. This address is the spender, that's the person spending. And finally, this value is like the amount that the person can spend. Of course, if I approve somebody to spend, let's assume this token I own only 100, and I approve person to spend 200, After the person spends 100, because I don't have that I don't have that balance myself, then the person will only able the person will only be able to spend the balance that I have. So it's not like you can spend above whatever that although you can set an allowance that is more than your balance, but the person won't be able to spend more than the balance. So it's, I really know. Now we've already used the approve. So this function can approve a spender to spend an amount. So next thing, now let's implement the allowance function, right? So with the allowance, we can get the value that was approved. So the allowance will take two variables, and so it's going to take the address owner, address owner. No, in fact, it has to follow the same signature as this. So let's just do this. I mean, it has to be structured like this. So that's the whole point of the RC20 being a standard. There is a way the sub has to be structured so that anybody can easily access those two other things. So this is no not approve. I mean allowance actually. Mean allowance. So takes the owner and the spender and returns whatever was approved. So it basically just returns allowances of owner to the spender. So let's assume should be with now. So let's assume I've approved somebody to spend a particular amount of my token. I will set it has been set here. So this thing is only going to return whatever value that was set. That's what it's going to return. So that's allowances. Now since we've done this, we can now implement the transfer from function. In fact, I will just okay, and an event has to be emitted as well whenever we approve. This is the approval event. So whenever anybody approves another person to transfer his token, we also have to emit an event. So the name of the event is approval. So we want to approve the owner, the person that is approving somebody, the spender, the person being approved, and the amount that is being approved. So after this approve, we just emit an event. We just emit an event approval. This is how you emit events. You emit events with this emit keyword and then the name of the event, and it's going to take these three variables, these three arguments that are here. So the owner is the msg.sender, is person approving, and then the person being approved is the spender. This spender is coming as an argument, and the value is the value that's also coming as an argument. So with this is called. So now let's implement the transfer from function. So the transfer from is taking underscore form underscore to and underscore value underscore form underscore because I didn't put I've noticed I didn't have the type. It's going to try an error. No, the form is meant to be an address, right? An address, and the total is an address, but the value is a unit 256. So let's just say unit. That's the value, and it's going to be public, so you can call it from anywhere. Now, the first thing that we should check when somebody calls transfer form is to check that whoever is calling it, does he have the permission of this form? Does he have the approval? So let's check that. Let's check that. So we're going to use the same require statement that we used before. So require that this allowances, I'll just copy it. So require that these allowances of the owner. Now this owner is the one you want to transfer his token. So that is going to be the underscore form, and the spender is me. I want to transfer somebody else's token. So that's going to be the address calling this transfer form function. That's going to be msg dot sender. So I guess this thing might be coming in this complicated. So if you have any question, please shoot. So now we can. So now, so that means with this line we're getting the allowances of this form to message the sender. So we need this to be greater than or equal to this value that the person wants to send. Else we throw an error with the error message insufficient approval actually. So if it passes this stage, that means the message of sender, the person that is calling this transfer, has actually been approved by this form to transfer his token, and the approval is up to or is greater than this value that is being sent. So we start, and we can just do the same thing that we did here. Now, after checking the approval, we also have to check that this form, I said you can even approve somebody for a value that is more than what you currently own. So we also have to check that this form, does the form own, balances. So this means this balance, I want to check the balance of form. So does this form, does it even have up to the token being sent? So we require that the balance of form 2 is greater than or equal to value. It's greater than or equal to value. Else I'll go to through an error message. Okay, let's continue. Go to an error message insufficient balance. So once we've checked these two conditions, we've checked that the person that you want to transfer his token has actually given you the approval, and then the person actually has up to this value, then we can just do the same thing that we did inside this transfer function. Balances. So instead of sender, it will be from, and then the value being using underscore value now. Yeah, and then this one is to so this is just the transfer form. So instead of the transfer where you're actually transferring from the caller, from person calling the transaction, this time around I'm transferring from this address to this address. The form address must have granted the message that sender the approval to transfer his token, which is what we check here. Allowances of forms message of sender quite as greater than or equal to value, and I will check that this form address actually even have up to this amount of tokens. Then if it does, then we'll remove it from this form and add it to this too. So I think with this we've implemented all the components. So of course some people might have extra scenario to actually only have 20 token. That's completely fine, but these are like the minimum requirements. These ones must be added first before you now add any logic that you want. So let's just do something inside this constructor. Once whoever is deploying these contracts, we want to give them some token inside the constructor. So basically, we can get whoever is deploying the constructor using mhd.sender. So one other thing, once you've transferred you've transferred these amounts, of course you want to reduce the approval, right? Because I mean, if I approve someone to transfer 30 of my tokens, 20 of my tokens, if the person transfers 10, then the person should be able to transfer only 10 more. So we have to reduce the approval. So I'm basically just going to do this. Let me just do this. Basically just going to do this. So we're going to reduce it minus equal to underscore value, which is seriously running lumen. Oh god. Yeah, so these things, and then so there inside here we just like let's whoever is deploying this contract, let's give him some token to start with. No, it's already, and the class was meant to end by it. So we just fast forward, and so balances of MSG sender is equal to, and let's just set in maybe a very big amount. Remember I said the token it works like it uses this decimal. So we're going to use something like 100 times 10 exponential 18. 100 times 10 exponential 18. So when I check the balance, when I outside the block, I saw it outside maybe on the front end or something. If I check the balance of this, if I call balance of with this MHD, if I call this balance of function with the address of the contract deployer, the address of contract deployer is what we have here as the mh.sender. It's going to only return 1000 because they would have made it easier. They would have moved it. They would have moved this decimal on the front end. But what the contract actually, all the contract actually stores is this 1000 with extra 18 zeros. So outside the contract, you probably see 1000 because the front end would have done the work for you. You see 1000. But what the contract is holding is 1000 times 10 is power 18. So let's just do that. So let's deploy. The contract is done. So let's just deploy sharp so that we can just let's deploy it quickly. So there's no need to compile. Let's deploy. Let's use the same name. Let's pass the same token name that we used the other time. Instead, I think I used BC OAU with the token. I mean BC OAU token with the symbol being BCC. Yeah, blockchain token. Yeah. So let's deploy. Let's deploy and let's just test out. So we have deployed. This was the first one that we deployed the other time. So this is the one. Transfer from no. Let me deploy. Oh shit, man. Yeah. So you can see these functions already. You can see these functions. So these are the functions that we used. With the name, we can get our name, the name of the contract that we passed. With the symbol, we can get the symbol of the contract. Now, in fact, I was even meant to add something. Tower supply returns 0, but it's not meant to return 0. It's not meant to return 0. I'm meant to set it. I'm meant to set because I've already, this is basically saying yeah, I'm giving the contract deployer this particular amount. So this total supply should give us this particular amount. So let's just total supply is equal to total supply is equal to this same value because that's total supply currently. Because I can as well add a mint function, allow people to mint, maybe people who have to pay to mint it or something. So I can as well add that as well. Let me just copy this thing so I don't have to type it. Nice. So let me just try picking. So we have the name BCOE token. The same thing that will pass in the constructor. We have the symbol BCT. Now, this is the contract that deployed this is the address that deployed the contract. If I copy it and I paste it here, then I'll get the balance. What is this? 100 times. This is wrong. 100 times 10. This is how the exponential inside solidity. Sorry about that. Let me play on that one again. Let me copy the address that deployed. Let me check the balance it should give. Yeah, so as you can see, because we set it here, the deployer of the contract, it should have this particular amount after deploying. So that's why I have it. So this value is also going to be the same thing as the total supply. If I check total supply, so this total supply of the token, this is the balance. So currently I own everything. So we've checked the man. So the decimal is going to return 18. So that's so what the front end does is after they get a balance, they basically divide it by 10 raised to power 18. That's what they display on the front end. The contract operates with this kind of value, but the front end is going to like so whatever you are seeing on the front end is going to be on the front end code. After getting the balance of, then they divide it by 10 raised to power 18 to give you the actual value that you're going to see. So that's actually what decimal does. So let's just try and transfer my. So let me transfer using this transfer. Let me transfer to this person to another address. Let me pick another address here. So currently, this address has zero balance, right? But once I transfer, of course, once I transfer to the person, what should I transfer? Let me transfer. Just no, let me transfer so that it can be clear. Maybe like four with a lot of zeros. So if I transfer, yeah, so the transfer has gone through. So this same address that I had zero before, now it's going to have another value as you can see. So this was what I transferred to it. So now let me use imagine this address. This address does not have any token. If it tries to transfer, the transaction is going to revert. As you can see, it's reverted because the person does not. If we check it, we are going to get that error that we. It has reverted because the address does not have up to the amount of token that it wants to transfer. So transaction is going to fail. So now let me approve. I mean, let's just. I think it's already approval and allowance. Now it's left. So now the account that deployed the contract, if you check his own balance right now, it would have reduced because he already transferred to this address. So let's check his balance. Yes, it has already reduced because it has already transferred. So that's just basically the gist of how this whole thing works. So let me see my just need to so because of time plus some things I'm not sure I will be able to like explain this transfer from like I wanted to. But I want to believe at least the little that we've done is even if it's not 100% clear, I want to believe it's a bit clear, at least reasonably.
Yes, a bit.
Okay. So I don't know, are there questions? Are there questions? No question at all. Okay, there's no question. I mean, our time is fast spent for
Yeah,
this.
thanks so much, sir.
Yeah, so it's just so what do we use ERC20s for? We use them. I mean, all these stable coins. We only have stable coins because there's something called an ERC20 token. That's why we can have our USDT, BUSD, USDC. So we use them for a lot of things. ICO, plus a lot of use cases. There are things you can just check. You can check online anytime you want to do more research. So I think this should bring an end to our class.